So the next two videos are going to be about a math fact in trigonometry or in general in all of math about certain right triangles that, quite frankly, it'll be in your best interest to commit to memory, because they'll show up enough that not only in this class but in all your math classes, that this is something that I would recommend that you would just kind of commit to memory. I'm going to show you why certain things are true here, but quite frankly, it's not the why that's going to help you down the line. It's going to be, I mean, it might, but it's going to be, hey, I know this fact and I'm good to go. So the fact in question here is this. If you have a right triangle and it happens to be what we call a 45, 45, 90 right triangle, I guess the 90 is sort of redundant if you call it a right triangle. Since these angles are the same, these two sides, the two legs, are the same. We can call them anything we want. We'll call them x. So let's say that means these two are actually the same length. And we can call this, well, let's not call it anything. In fact, what would this be? What would the hypotenuse be? Well, hypotenuse, c squared in this equation, right? So c squared, the hypotenuse squared, is going to equal a squared plus b squared. But they're the same thing. So it's really x squared plus x squared. Okay, now an x squared plus another one of these x squareds, since they're the same kind of term, is just 2x squareds. This is the point at which my smartboard starts to misbehave. Let's slide over here and hope that it comes out a little better. See, I'm going to pause you for a second and see if I can fix this. Now, hopefully I fixed it. We'll see. C squared is equal to 2x squareds. All right, take the square root of both sides to get the hypotenuse by itself. So c is going to equal the square root of 2x squared. Now, a couple of videos ago, I said you couldn't break up the square root over an addition or a subtraction, but you are more than welcome to break it up over a multiplication or division. So, for example, I could rewrite this as the square root of 2 times the square root of x squared. Perfectly legal. But the square root of x squared is, of course, just x. So really, c is square root of 2 times x, which, because of the weirdness with the radical, we would write x square root of 2, just that way we don't think that the x is inside the square root. Oh, wait a second. I used x. So this is the advantage to using a variable. I just came up with a rule that is the same no matter what x is, because I didn't know what x was. And that is that if I know one side, not the hypotenuse, but one of the legs of a right triangle, I automatically know that the hypotenuse, just take that leg size and multiply it times the square root of 2, and that will give me the length of the hypotenuse, and that will always be true. So if this was 5, the length of this side would be whatever 5 times the square root of 2 is. Now, we could get a decimal for that, but the truth is, in math, they say, I want an exact answer. They want this. They don't want some irrational, they want some decimal that technically would never end, because 2 is irrational when you take the square root. So this is what we mean by an exact answer. So I go from leg to hypotenuse. If I know a leg, I get the hypotenuse by multiplying by the square root of 2. It makes sense. So the hypotenuse is going to be larger. Square root of 2 is like 1.412 square root. Yeah, 1.41, blah, 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 blah. So it's going to be bigger. What if I have it the other way around? What if I have a 45, 45, 90, and let's say I know the hypotenuse instead. Let's say, I'll call that hypotenuse, we'll use a number here. Let's say it's 11. What would one of the legs be? Well, I know if I go from the leg to the hypotenuse, I would multiply by the square root of 2. So if I'm going the other way, I'm going to do the opposite. I'm going to divide by the square root of 2. So this side here would be 11 over the square root of 2. And what would this side be? Well, it's 45, 45, 90. They're the same. So the key here is you're either going to go from either multiply or divide by the square root of 2. How do you remember to do which one? Well, think of it this way. I'm going from what has to be the longest side. Multiplying by square root of 2 is going to make that number bigger. Dividing by the square root of 2 is going to make it smaller. I think I want to divide if I'm going in this direction. And then if I'm going the other way, just use a little bit of logic, a little bit of reasoning. You'll be fine. Now I'm going to do a small disclaimer here. Math people, for reasons I cannot explain, and if you can get your math teacher to explain to you why it is important to do this, I will give you $20. Because I'm telling you right now, there's no good reason. And that is, they would tell you that 11 over the square root of 2, that there is something quote unquote wrong. Basically, it's like some sort of decorum. It's like if you had like tea with the queen and you didn't raise your pinky. Like there's no reason why you would need to raise your pinky. It's just going to offend the queen, I guess. But that's not really a reason. Writing this would offend some math teachers. So they are going to make it harder on you. See, they're going to say you can't have a square root in the denominator, in the bottom. I don't know why not. They don't like things in their denominator. Too bad. But the way they can get rid of that is they multiply top and bottom by the square root of 2. And they would write this as 11 times the square root of 2 over 2. So see, I contend that this, if you see this, do you really think in your head, oh, I just divided by the square root of 2? No. No, if I wrote this as 11 square root of 2 over 2, you would have no idea what I did to get that number. And you would be confused in math class, which is why math classes can be confusing. One of the reasons. I taught math, and my mom was a math teacher, so don't tell me I'm being mean. Point is, in my class, you're perfectly fine to write that. I do not worry about what's in my denominator. That's not a big deal. I am much less uptight than math teachers. But if you see it in a math class, they'll tell you, you didn't rationalize your denominator. Part of me wants to tell you, well, anyway, no, I won't. Just play the game. But going from the long side to the hypotenuse, that is, to one of the legs in a 45, 45, 90, you're going to divide by the square root of 2. Going the other direction, you're going to multiply by the square root of 2. You need to commit this to memory. You need to practice this. So if I gave you, for example, a 45, 45, 90, notice I'm changing the position of them all the time, but not that that's that difficult. And I said this was 17. How long is the leg? 3 seconds. 3, 2, 1. I'm going to divide by the square root of 2. 17 divided by the square root of 2. Got it. What if I said this was B? Pick a letter. Doesn't matter. What's this going to be? 3, 2, 1. Did you tell me? All right. You said I'm going to multiply by the square root of 2 going that direction. So it's going to be B times the square root of 2. Sweet. I think you got it. All right. Now practice it, because you won't really get it until you practice it a bunch of times.